the methods in C programming language. Methods are functions that are associated with a particular type. Classes, structures, enumerations can all define instance methods which encapsulates specific tasks and functionality for working with an instance of a given type. Classes, structures, enumerations can also define type methods which are associated with type itself. Type methods are similar to class methods in Objective-C. So we have two types of methods. One is the instance method and another one is a type method. Structures enumerations in C can define methods. This is different from C and Objective-C where classes only can define methods. First we can check the instance method. Instance methods are functions that belongs to the instance of a class, structure or enumeration. They support the functionality of those instances either by providing ways to access and modify instance properties or by providing functionality related to the instance's purpose. So here is a class as having an property count and having a method called increment. So this is a method. This is an instance method. Inside this method I am going to change the count by 1. And also there is another method increment. The argument label, this is a param of type int. In this method I am going to change the value of count by amount. And also have another functions for method reset that sets the value of count by 0. So in this class we have 3 methods. One is increment, another is increment by an amount, and another one is reset. So these are all instance method. Let's see how we can use that. We call the method by instance name dot the name of the method. If there is a param, we by 20 and dot reset. Okay, this is all about the instance method. One thing need to consider is the self property. Every instance of a type has an implicit property called self, which is exactly equivalent to the instance itself. For example, if I want to get the count property, I can tell the self dot. Okay, both are the same. You use self property to refer to the current instance within its own instance methods. The use case is the self distinguishes between a method parameter and an instance property. For example, if I change the param by count, see this, the parameter and the property having the same param name, so it will the use of the self will distinguish between a method parameter and an instance property. Now that is the use case of the self. Let us now we have checked with the methods in classes. Next we go. I'm going to create and the structure. Structure is a point, sorry, here properties x equal to 0, y equal to 0, and I have a function move by, sorry, I'm saying method move by. I'm going to change the value of x and y on this function, this method. We can put delta x inside double y, delta y is say double. So I'm going to change the value inside this method x plus equal to delta x and y plus equal to delta y. So this is error actually. See, this left side of a mutating operator is immutable. Its method self is immutable. Mark method mutating to make self mutable. That means structures and enumerations are value type. By default, the properties of value type cannot be modified from within its instance method. You can use mutating behavior to modify the properties of your structures and enumerations. So just put mutating, sorry. Okay, now it's possible to change the properties properties from inside the instance method. Let us check. Some point dot move by 2 and 2.0 and 3.0. Let's print that some point dot x and some point dot y. So value will be 3 and 4. Got it. There is another behavior here. Mutating methods can assign an entirely new instance to the implicit self property. For example, in this function I am going to change the full instance. I am going to change self equal to new point. Okay. X plus delta x y plus delta y. So here I have changed the self to a new instance. Okay, so the mutating methods can assign an entirely new instance to the implicit self property. That's the power of the mutating. So we have seen the instance method in class structure. Next we are going to check with the enumeration. Some state switch with with cases of low and high. Okay, and I am declaring an mutating function. Next, we switch it. Self pattern. If it is off, I am going to change to state equal to self equal to dot low. Same for off to low. When it's low, will be high. Then it is high. Sorry, it's to off. So the mutating methods for enumerations can set the implicit self parameter to be different case from the same enumeration. Let's check this. Var light is equal to try state switch dot low. Then light dot next print light. If it is low, we change to high. So this mutating function have changed the case to another case within this instance method. So mutating methods for enumerations can set the implicit self parameter to be a different case from the same enumeration. Next is the type methods. As we see in there, instance methods are methods that you can call an instance of a particular type. The methods that are called on a type itself is called type method. You can use a static keyword before the method's name to make it as a static method. So, an example, you have a class, some class having a static function or static method. By declaring it as a static keyword, type method. So this is how we declare a type method using the static keyword. To call this method, we use the name of the class with a type method. Okay, also the classes can use class keyword instead of this static keyword to allow subclasses to override the superclasses implementation of that method. So I have another class. The class is extends some class and override that function. Some type method. Okay. And hello. So I'm calling superclass dot some method. It will be hello. Okay, if I used that static keyword, then it won't be able to subclass it. Cannot override static method. We should use that class in order to subclass on the inherited class. Let us check some other properties. We have a structure, some structure. We have a static uh, property called p1 is value of 1, and a normal property, instance property p2 equal to 2, and we have a static function method type method. So I'm going to call the the instance property inside a static method. Is possible? No. Instance member p2 cannot be used on a type. Okay, so then any unqualified method or property names that you use within the body of a type method will refer to other type level method and properties. So should be a type level method or property. The methods on structures and enumerations can access type methods by using the type properties name without using a type name prefix. Some P1, right? So we call the type property using this type name. We can also use without the type, we can access that property inside the enumeration or a structure. Also for that, same for the methods, we have another static function type method 2 and print, just calling that some structure dot type method. Here you don't have to provide this some structure, we can directly call that method inside static method. Got it? It will work. So okay, this is all about the methods. Thank you.